Senko AP Physics Experiment number 24, Planck's constant. Students will measure the wavelength and threshold voltage of an LED and use these values to calculate Planck's constant.
The kit includes Planck's constant apparatus with LEDs attached, wires, diffraction grating, and 2 multimeters. Required but not included is a 9-volt DC power supply or 9-volt battery.
This activity allows students to investigate how an LED works as well as how to approximate Planck's constant by looking at the threshold voltage of different LEDs and different wavelengths. Now, one really great thing about this setup, besides it being self-contained, is you can just run it off of a regular old 9-volt battery connected to the power supply. You don't need a big power supply to make this run. You turn the switch on and you can adjust a built-in potentiometer, and there are wavelengths denoted for each one of these LEDs, but if you want to verify them, you can always use a diffraction grating to measure the distance to the LED to the screen and the first order maximum to verify the wavelength. So what you'd have the students do is measure the current across each LED and the voltage across each LED, and I'm going to increase the internal resistance on this until the bulb starts to dim. I'm going to see a decrease in my current. What I want to do is find that voltage where this is going to be basically 0. And then that is my stopping voltage that I want to use. You click to the next bulb, increase the voltage up, now decrease it down until you don't see the light bulb anymore. But more importantly, you want to get this current just down to 0 and then record the corresponding stopping voltage. When you do that for each one of these LEDs, you get a really nice graph that gives you a great approximation of Planck's constant.